You probably noticed by now that we haven't talked too much about the Numpy package. When you use Pandas, there is no escaping Numpy arrays since the Pandas library was basically built on top of it. That is why you will generally see people import the Numpy library along with the Pandas library each time, using an alias for Numpy as NP. The Numpy library gives us an array data structure which is very similar to a list, except it has more subtle benefits such as being more compact, faster access for reading items, and being more memory efficient. This may not seem like a big deal, but it certainly makes it different at large scales. To make a Numpy array, we use the np_array method. We pass a list to it and boom, we're all set. We also have the option of specifying the data type of the data, but with our MBA stats they will all be rather uniform. When you print in an array, you will notice the data are integers. The array holds the data in a structured way which allows for complex mathematical computing. And that is what we will be using arrays for in our model. We will apply built-in NumPy methods to arrays that help us quickly calculate certain stats. This means we can also use normal operators, such as add, subtract, multiply, and divide, easily by just running np add, np subtract, np multiply, and np divide on our array. We can also take the square root of our arrays with np square root, something that will come in handy when measuring our model's performance. We aren't going to do much else to the arrays as far as indexing, slicing, and splitting them, but if you're interested, I recommend checking out DataCamp for more. So let's run through some basic operations after importing our NumPy array. Let's create a list of steals stats for Kawhi Leonard over the last 5 games. So if we say Kawhi steals equals 4, 5, 2, 1, and 3, and we run that, and again you'll see we started as a list that we can print, and it comes as a list. Now to create an array from NumPy, basically all we are doing is taking that np array method and passing it in the steals. And again, we'll save this as a claw NumPy array. And now if we print the claw, you'll see we have an array. So what this means is we can calculate on the array. So let's say we took the mean, that's 3.0, and we can also do an additions to the array. So let's just say Kawhi had 2 more steals each game. Print that, and what did that do to his average? You'll see it increased it to 5.0. We will be creating arrays for players' entire season stats and then comparing those to the other players' stats to find similar player seasons. To make sure all the operations work, we can always check the shape of the array. So let's say we had some player stats that were just equal to some random array, and then we wanted to get the player stats shape of the array. We know it's a 3x4, and then let's say we have some other player stats, and we set that equal to a different array, and we get the shape of this. And we see it's also a 3x4. That means we will be able to do some easy calculations that work because they are the same shape. Great. Everything you've learned until now is going to help us with our projection model. We will be taking these building blocks and putting them together like Legos to get our end model. If you are still unsure about anything we've reviewed, take some time to dig deeper using Stack Overflow and the internet.